Hi, Daniel. Sydney's here from Montgomery. Welcome. All right, Mia's here from Springfield. Welcome to Mia. Okay, I think we are ready to get started. So good morning, everyone. Welcome to your Electrical Engineer Research Team meeting. My name is Rachel, and I'm an educator here at the Franklin Institute. So glad to have all of you engineers here today to share with us the work that you've been doing on electrical engineering. So for those of you that are joining us on our Zoom call today, welcome. You might notice that we won't be able to see each other's faces or talk today, but we're going to use the chat as the way that we can share our ideas. So if you have something to share about the research that you did or about science in general, the chat is the place to do that. But if you have something that's not about science or research, let's save that for another time. So this chat is going to be about science and about our research in electrical engineering. And you can also definitely introduce yourself so we know who all is here. Welcome to the Newman family, Braden, Taylor, and Mackenzie. Hi, Evelyn. Hi, Lewis. Welcome to all of you. We're so glad you're here and joining us on the Zoom call this morning. And for those of you that are watching our live stream, welcome to all of you. Also, we're glad that you're here. Even though we won't be able to hear from you in the chat, we hope that you all are having these same conversations with your groups in your chat. So welcome to all of you. So before we get started, I wanted to let you all know that we are not the only research team that has been working on these engineering projects this summer. There are research teams all around the country who are doing these same activities and these same experiments. So all of those red dots that you can see on the map are places where kids just like you are doing these engineering activities this summer, everywhere from Maine to Oregon to Texas to Florida. So lots of people working on solving these problems. Good, lots of other people introducing themselves. Hi, Brooke. Hi, Alyssa. Hi, Joseph and Meg. Welcome to all of you. We're glad you're here this morning. All right, so this is our electrical engineer research team meeting, which means that we were practicing being electrical engineers. So what do you remember about what kinds of problems electrical engineers solve? Go ahead and let me know in the chat. What kinds of things do electrical engineers do? Or what problems do they solve? Catherine says their dad is an electrical engineer. Awesome. What kinds of problems does your dad work on, Catherine? Problems with electricity. Maybe they fix cars, says Elizabeth. Gloria says they work with wires. So you can maybe see that in that picture there, right? So maybe electrical engineering involves working with wires. Wonderful. Any other ideas about what kinds of things electrical engineers do? Maybe they work with coding. So they might have to work with computers, and maybe that involves computer programs and coding. Braden says electricity problems, power outages, all things about electricity. Morris says they work with circuits. Yeah, we definitely did some work with circuits in our project, didn't we? Maybe they work on phones. Traffic signal coordination, says Gloria. So thinking about how traffic signals work together. Wonderful. Lights, hardware. Maybe they could help with heating and air conditioning, right? So heating and air conditioning systems all use electricity. Motor control, says Sydney. Electric engines, technology, iPads. Yeah, think about all those things that use electricity. Anything that uses electricity is something that an electrical engineer might work on. Wonderful. So as we think about the work that we did as electrical engineers, I have a question for you all, and I'm going to put up a poll that you'll have a chance to answer. So the question I'd like you to think about is, when you were doing this electrical engineer activity, did it make you more interested in being a scientist one day for your job? So you should hopefully see that poll box pop up there, and you'll have a chance to choose from. It made you a lot interested in being a scientist, a little bit more interested in being a scientist, or not at all. So go ahead and answer that poll if you can see it. And if you don't see the poll and you'd like to just answer in the chat, feel free to do that too. So did this activity make you more interested in being a scientist one day? Joseph says they were already really interested. That's great. Yeah, Brandon's still thinking about what electrical engineers do. So maybe they're thinking about other ways to make electricity besides fossil fuels. Right, Joseph? So if you were already a lot interested, maybe didn't make you more interested, but you were already interested. That's great. All right, we'll wait just a few more minutes. Just make sure everybody gets a chance to answer that poll. And then we'll go ahead and show you the results. Kathleen says maybe electrical engineers work on wind power. Yeah, so that going back on what other folks said about other ways to make electricity besides burning fossil fuels. All right, so let's close the poll and let's see what you said. All right, so hopefully you can see those results there. It seems like most of you at least are a little bit more interested in being a scientist because of having done this activity. Wonderful. All right, so let's talk about that activity, the research that we did. So you might remember that our job was working with a hospital. So our team was working with a hospital to think about the buzzers that their patients can use when they call for help. And you might remember that the design of the buzzer that they had wasn't working very well. So part of our job was to make a model of the buzzer and see what wasn't working well so that we could find ways to make it better. So let's think a little bit about that. And before we do, I'm just gonna, oh, there we go. All right, so I'd like to hear from you all what you found out. So you might remember that our first job was to make a model of the hospital's buzzer and see what parts weren't working well. So if you all did this activity and maybe you wrote down some ideas or some thoughts in your lab notebook like this, you might want to have those ready to share. If you don't have a lab notebook, we still want to hear your ideas in the chat as well. So let's start by thinking about that first model. When you first built the model of the hospital's buzzer, what were some of the parts that didn't work very well? Go ahead and tell me in the chat, what were some parts that didn't work and what did you do to fix it? Yeah, Joseph says they found out that that electricity goes through metal. Interesting. So you have to make sure that all the metal parts are touching each other. Jim says it isn't working yet, so you're still fixing it. Yeah, so some of you found it was not easy to connect the wires to the battery, right? So when you talk about a circuit, right, we're thinking about all those pieces need to be connected so the electricity can flow in a circle. So it seems like getting the things connected so that the electricity could flow is maybe part of the problem. Not easy to stay connected. Sometimes the wires wouldn't connect to the battery. Lori, I thought maybe it was hard with the tape. Shell says maybe they had taped the wire and realized it wasn't working with the tape on it. The tape was getting in the way. So you found out that the buzzer wasn't buzzing. Seems like lots of people had some problems with getting all of those pieces to connect. Yeah, so maybe the tape wasn't quite strong enough. Megan says it was loud. That's something to think about, right? If this is a buzzer that hospital patients are using, is it going to hurt their ears to press it? Yeah, maybe we just need a different buzzer that's not so loud. That's a good thought, Mia. Oh, sorry, that was Megan. Brandon says they crimped the wire and the fastener together. Okay, so you got it nice and tight. Someone says one problem was that the battery died. Yeah, so that's something to think about too, right? What happens when the batteries run out? Sometimes it glitches out, says Megan. All right, so I'm seeing lots of different things that you tried, problems that you were trying to solve. Katrina says, yeah, so the red and black wires kept falling down, so you tried a different kind of tape. So maybe the masking tape that we were using wasn't very helpful as our model. You used a stronger kind of tape. Angela says maybe a problem was it didn't work because the wire was on the wrong side of the battery. So we figured out that maybe it matters which part of the wire is connected to which part of the battery. All right. Jay and Aaron were thinking about the switch, right? So that was part of the problem. Beth says without a switch, the circuit is always on, so it's always beeping and draining the battery. And you have to think about how you can make that so that it turns on when you want it on and off when you want it off. Sometimes the wires make noise, Autumn. Interesting. All right, looks like Mia was adding some parts, including using a different kind of battery, so a stronger battery because you added a light, an LED light as well as a buzzer. Interesting. Natalie used a circuit board. Very cool. All right, so I'd love to hear, we'll hear some more about some of the solutions that you came up with. in just a little bit, but I'm hoping that maybe all of you can help me with the project that I am working on, because I've been trying to solve some of these same problems, and I'm hoping that you can help me. So I'm going to switch my camera in just a minute. So I'm going to disappear for a minute here so that you can see the project that I'm working on. There we go. All right. So one of the things I noticed that I think a lot of you noticed too was that the original model with those two fasteners, the fasteners were kind of wobbly. It was kind of hard to stick them together. So one of the changes that I made, and I think I saw some of you say in the comments too, was that I used paper clips to hold my wire down. So if you can see what my model looks like, I moved my battery right up to the edge. And I have my black wire connected here to the buzzer, and then the red wire is being held with paper clips. And the switch that I'm working on is this little piece of aluminum foil right here. So my idea is that when this is closed, the buzzer would look like this, and the person could just press this switch like this to touch it to the battery, and that would turn it on. But you might notice that I'm touching this to the battery, and right now, when I touch it to the battery, nothing is happening. Did any of you have anything like that? Have anything happen like that? And if you did, what did you do to try to fix it? So it seems to me like I should have a circuit, right? I have a battery and the black wire and the buzzer and the red wire, and I have my switch. Seems like this ought to connect the circuit and it ought to turn it on, but right now it's not doing anything. Elise says they switched the battery around. Mia, if you have an idea, put it in the chat. Megan says you just didn't fold the plastic. Switched the wire and took anything off the wire. Maybe the aluminum foil might be blocking it. Ah, so sometimes maybe the wires are just not connected together. Interesting. Oh, yep, and look what just happened. So maybe it looks like my pieces were not as tightly connected as they could have been. So let me see if I can connect that a little bit more tightly. And we'll try again. Try pressing the foil tighter to the wire. All right, I'm going to see if I can attach this a little bit better. And I know some of you said in the chat already to make sure that the tape was not getting in the way, right? We have to make sure that metal is touching metal. So I'm going to make sure my tape only goes on one side here. Now, hopefully I've got my wire connected nice and tightly. And let's see what happens if I press this time. Nope. Still no buzzing. Interesting. Maybe the masking tape is not conducting enough electricity. Maybe the paper clip is squeezing the wire. Interesting. So maybe I could loosen the paper clip a little bit. Try that. Oh, I don't know if you can hear that, but I'm getting just a little bit of buzzing. So it looks like your suggestions helped me fix that circuit. So maybe it was a little bit too tight. It wasn't connecting properly. Oh, and now it's not buzzing again. Any other ideas what I could do? You did hear it, Megan, good. Wasn't sure if that would be picked up on my microphone or not. It needs to be on the bump on the battery, right? So maybe it's just not quite getting to the right part of the battery. Maybe the tape is blocking the sound. All right, let me see. Try to move the tape there. No, we had it for a minute, but taking the tape off the buzzer. Interesting, I wonder where that would help. I'm a little bit worried if I take the tape off the buzzer, that it's gonna wobble around, but we can see if that makes a difference. Maybe it's just too quiet, you mean? Let's try that. Maybe if that's where the noise is coming from, I can put it that way. Gloria said, try a paper clip. Ah, so maybe if I use a paper clip instead of this piece of aluminum foil. We have another paper clip. Let's try that. Let's see, I've got a small paper clip and I've got a big paper clip. Does anyone have an idea about whether I should use a small one or a big one? Yeah, so Eilish, you know, we did try the aluminum and it was working a little bit. So it seems like maybe we can actually conduct electricity with the aluminum, but something else might be going wrong. Yeah, some other folks have said that aluminum foil worked for them. Small, says Evelyn. So I've got small and I've got big. The wire inside the two ends of the paper fastener and put the tape like a wrap. Oh, okay. So we tried the aluminum foil first, or the paperclip suggestion first. So let's try that first. And if that doesn't work, maybe we'll try another thing for our switch. Whoop. All right, so let's see. I wonder how I'm going to connect the metal end of the wire to my paperclip. I'm in a little bit of trouble figuring out how I'm going to get that to stick there. Wonder if that would do it. Twist them together. Yeah, unfortunately my wire is a little bit short, but that's a good suggestion. I think I've got it twisted as good as I'm going to get there. All right, let's see what happens. No, not hearing any buzzing there. Any ideas what I could do? Something I could do with a paperclip or something else that I could try? And I suggest flipping the battery. Yeah, that's an interesting suggestion. My thinking is because we made it work this way once, probably this is the right way. We just have to figure out what part of the circuit is not connected that's keeping it from beeping. Someone else wants to try the wire fastener. All right, let's try a different kind of switch. So we'll keep this in mind. We haven't maybe figure out if there's a good way to use the paperclip. But since someone else suggested the brass fastener, let's try that one too. So I think we had a suggestion to squeeze it between the two parts of the fastener and tape it together. Let me try that. So I like that we're trying lots of different ideas for what could work for the switch. All right, so we heard make a sandwich and squeeze it really tight. All right, I'm not going to tape it all the way just in case we need to change it, but I've got it sandwiched in there. And let's see what happens. Still not hearing any buzzing. I do have it squeezed, so I'm trying to test it with no tape first. That's a good idea. I kind of got it all stuck here, but maybe I should have tested it with no tape first. All right, so we've tried a couple of different switch ideas. We might come back to those. I'm wondering if there's anything else in our circuits. We've tried different switches and that hasn't fixed it. If there's some other part of our circuit that's causing the problem. Anyone have any ideas what else I could check to see if there's someplace else? The red is supposed to be on the positive side. Well, let's test that. We think we made it work this way before, but it never hurts to try. So I'm just going to untape this, see if I can test it without taping it together. So what happens if I switch the wires? So I'm going to put the black on this side. Whoops. And the red on this side. I definitely don't hear anything there. What happens if I switch it back? I'm putting the black on the flat side and the red on the bumpy side. Ah, yep. So the black definitely goes on the back side and the red definitely goes on the bumpy side. Because if I do this, I can hear it. So we know that that's the right order. We just have to figure out what parts of our connection weren't being tight enough. Trina says that's what happened to you. Yeah. So we know we have it lined up right. Let's see what happens if we just stick it back together. Angela says, you have a blue wire, put it on the positive part of the battery and tape the black one down. So I'm going to tape it down a little bit. See if we can tape it down to make sure that connection is nice and tight. All right, let's try a little test. So I've taped that down. We know it works if I hold the two pieces. What happens if that one is taped and I just touch this one? All right, so it sounds like the black connection must be nice and tight because that works. Duct tape, yeah, I didn't think to bring duct tape, but that might have been a good idea because I think you're right that duct tape is a little bit stronger than the masking tape that we're using. So that might be a good improvement for me to work on a little bit later. Mia says maybe go back to our original idea and try using the aluminum foil around the red part without tape. All right, let's try that. So what if I just fold it over without the tape? Ooh. Doesn't seem to want to stay in there very well. Okay, so that was a good test, Mia. So I'm not using any tape, I'm just pinching it together with my fingers. So that was a good test because that tells us that this can work with aluminum foil. Awesome. So I could try a brad, maybe electrical tape, some of you are saying would be a better choice than the masking tape we're working with. All right, so we know we can crimp it. Now, the only problem with the crimping is that it doesn't stay there, it slides right out. So I think we're gonna need some kind of tape to hold it in place so it doesn't fall apart. But I like that idea, Mia, of just folding it over. So maybe a piece of tape will hold it a little bit better. Let's try it one more time. So you guys are giving some great ideas for other kinds of switches that I can use too, if this one turns out not to work. Maybe I'm going to try the paper clip or the brass paper fastener. All right. Great. Well, thanks for helping me troubleshoot. So now it seems like it's working. Oops, there we go. So it seems like it's a little bit tricky where exactly we touch it, but it seems to work better than it was working before. Awesome. All right. Well, I think I probably still have a little bit more work to do on some of those. Yes, Mia, I think you're right. Electrical tape. So I think maybe if I keep working on this, I'm going to try some different tape because it seems like all of our pieces were in the right place. They're just not being held on quite as tightly as we'd like. Great. Yeah, Michelle. So that's the next step that I haven't thought about, right? We're still working on making it work, but you're right. It's not very nice to look at right now. We want to think about what would make it look a little bit more attractive. That would be the next step. All right, well, you guys have given me some great ideas to keep working on. So I'm maybe gonna try some different kinds of tape and think about how I can make all those connections nice and secure so that they keep working all the time and not just some of the time. Well, thanks for helping me out with my problem. I would like to now hear some more from you about some of the things you tried. So I'm gonna switch my camera back again. So give me just 1 second. It's gonna look funny for a minute. All right. So now I've already heard some of the things you tried, but I'd like to hear some more from all of you about some of the things you tried. First of all, we know that engineers don't just try once. They try over and over and over again. You definitely saw me doing that just now. So just a question for you. How many different ideas do you think you tried in what you've done so far? 1, 10, 100, a lot? Go ahead and tell me in the chat, how many different ideas do you think you tried? Rubber bands, paper clips, metal binders, so at least 6, 2 or 3, 4 or 5. Mia says like 15, 11, 3, 2, at least 10, 1. Some of you maybe haven't tried it yet, and that's okay too. So maybe you're watching this before you've had a chance to work on it. 12, 6 or 7. Yeah, and I bet even those of you that tried one idea and your first idea worked, you probably made some changes to it to keep it better, right? So you made a completely different model on the second try. This is Lewis. 3 or 4. Oh, that was 3, not 13. Okay. Yeah. So we definitely tried lots of different ideas. So what are some of the things you tried? And if you told me already, feel free to tell me again. What are some of the things you tried that didn't work? So we saw, I tried some different shapes for my buzzer. You can see some of the pictures on my screen there. What are some things that you tried that didn't work? Sydney was trying to make the buzzer work using the back of your hand or just one finger, right? So if someone is sick, maybe they can't use lots of fingers to be able to just press it easily. That was something that you were working on. Gloria, yeah, the tape didn't make strong connections. I think that's definitely something that we all found out, right? Maybe a stronger kind of tape would help to make this buzzer work better. Kelly tried using Play-Doh to hold the wires. Interesting. So that was something you tried, but it didn't work. Great. Mia says their first idea worked, but they thought they could still make it better, and they did. Nice. All right. So Frank found out that aluminum foil conducts just as well as the wire. Putting the wire on the wrong side, we tried. Gloria said maybe the paper fastener was too clumsy. So that was what we started with. You started with a paper fastener, and that was one that didn't work as well as you would have liked. Sydney says they tried to attach the buzzer to a base with a cover, almost like a clapper. Interesting. I'd like to hear more about how that worked. And Priyal said, place the aluminum foil between the wires and the battery instead of the tape, and then discovered it was a conductor, right? So instead of holding it down, it actually let the electricity go through. Right? Taylor says you have to squeeze it tight, so you tried 3 or 4 times because you could just barely hear it at first. Nice. All right. Anything else you want to share about what you tried? So we asked what some things were that didn't work. What are some things that you tried that you liked a lot, that you thought worked well? This used alligator clips with the battery taped in a cup with aluminum foil to make a button. So it sounds like a little bit like the idea that I was working on. Some of you are still solving some problems, right? So some of you still having trouble that it's not buzzing as loud as you would like. Making a button out of foil. Gloria tried, since like a lot of you tried making the button out of aluminum foil like I did. Tamora says getting it fastened down so it all stays in the right place. Yeah, some of you added some pieces to yours, like a circuit board. At least use the cardboard on top as the button. Oh, that's really interesting. So you could press the cardboard top and have it work just like a push button. I like that idea. Anirudh made a bare wire and brass fastener button. It's all different kinds of ideas for different buttons and switches. And some of you had the same ideas. So definitely some people used aluminum foil as a button. Some of you used fasteners. Some of you had your own ideas. Wonderful. Well, it sounds like we have lots of different ideas that we could tell the hospital about how they could make their buzzer work better than it did before. So Sydney was thinking about putting the switch on a base with an aluminum foil cover so it opens and closes easily. Elise said they had an idea that worked perfectly, but it went against the rules. Yeah, that's interesting, right? In engineering, we have requirements, right? The things that it has to do in order to be what the people want. And you can have a great idea, but if it doesn't fit those requirements, it's not going to be quite the best idea. All right. Well, thank you all for all of your ideas. I'm definitely going to keep working on my model with the ideas that you have given me. We have some good ideas to give to the hospital about making this buzzer better. So I wanted to tell you a little bit about someone who is an electrical engineer and does similar kind of work to what we did in our research project. This is Zaida Hernandez. She lives in Wisconsin, and she is an electrical engineer, similar to what we did today. But she didn't always live in Wisconsin. She actually lived in Mexico and moved to the United States when she was 11. So when she moved to the United States, she didn't speak any English. She had to learn and go to school and learn an entirely new language. She said that having to go to school and learn a new language all the way from scratch is one of the things that helped her learn one of the things that engineers do, which is to be persistent, to try again and again and again, because she had to try again and again and again while she was learning to do school and all of the things that she normally did in English. So when she was in high school, she got interested in biomedical engineering, which is a kind of engineering that thinks about devices or tools to help people who have medical problems, a little bit similar to the kind of thing that we did with our electrical buzzer. But that wasn't the only thing she was interested in. She also became interested in the electricity part of biomedical engineering. So she studied to be an electrical engineer. And on top of that, she was also interested in being a barber and cosmetologist. So she studied all three of those things, biomedical engineering and barbering and cosmetology and electrical engineering. And she actually worked as a barber while she was studying to be an electrical engineer. So now she actually works on the machines that make airplane parts. So you can see a picture of one of those machines down in the corner of my screen there. So she helps with the wiring and the connections to make those machines, and those machines make parts that make airplanes. So if you'd like to find out a little bit more about her and how she got to be an engineer, there is a short video that you can watch. We're going to put the link in the chat for you. So if you want to watch that later, you can. But what I think is really interesting is that it's possible to have lots of different interests and be an engineer, right? Because there's all different kinds of problems that need solving. So we need all different kinds of engineers with all different kinds of interests to help us solve them. So whatever you are interested in, there's probably engineering that you can do, whether you're interested in music or sports or makeup or dance. All of those things have problems that need solving. And then that means there are engineers to help solve those problems. So let's think about how you were like a scientist today. I have a couple more questions that I'd like to ask you by a poll. And the first question is, how did you think or act like a scientist when you were doing these electrical engineer activities? So if you did use your lab notebook, you might notice that there were some stickers that came along with the lab notebook that had things that scientists do on them, things like had an idea, tried again, observed. So those are going to be the answers that you can choose from this question. And you can choose as many of these answers as you like. So the poll question is, how did you think or act like a scientist when you were doing your be an electrical engineer activity at home? Did you observe? Did you test? Did you try again? Did you ask a question? Did you have an idea? Did you learn something new? Did you work together? Did you have fun? And again, if you don't see the poll or if you would just like to share, go ahead and tell us in the chat which of these things you think that you did. Yeah, Megan, I'm sorry we aren't able to see a picture of the project in the chat, but you can always tell us about it. Joseph did a lot of thinking. Yeah, we didn't list that as one of the choices, did we? But that's definitely part of being a scientist. Observed. Yeah, sorry, Nathan. Unfortunately, we can't rename, so I can only see the name that comes up on the screen, but I'll try to remember that. Dexterity. Yeah, interesting. So that means being able to work with your hands. So that's something that scientists need to do, that especially if you're working with wires who maybe needed to practice. Taylor asked, what if? Yeah, so asked a question. What if this? What would happen if? Those are great questions to ask. All right, let's wait just another minute. And all right, let's see what you said. All right, so if we take a look at our results, the red one, the one that the most of you chose, looks like most of you tested things, but a lot of people did lots of these other things too. There was lots of trying again. We definitely saw that happening and heard from you in the chat about all the different ideas you tried, asking questions. Lots of us had ideas and lots of us had fun as well. Great. All right, so one more question. So now we've thought about how you were like a scientist. Now I'd like to ask you, did this activity show you that you can do science? And this time you'll have a choice of a little, a lot, or not at all. So did this activity show you that you can do science a lot? Did it show you just a little bit that you can do science, or did it not really show you at all that you can do science? So go ahead and put your answer in the poll. And if you don't want to put your answer in the poll or you can't, feel free to add it to the chat as well. So many good ideas in the chat that I even missed. Interesting. So Beth says their dad originally went to college to study airplanes. I wonder if there was any electrical engineering involved in what they studied. All right, we'll take just one more minute to make sure everybody gets a chance to answer that poll. And let's go ahead and see what you said. All right, so about half of you said a lot, about half of you said a little bit, and a few of you said didn't really show you at all, and that's okay too. Great. All right, well, we had a lot of good opportunities to practice doing the things that scientists do and think about how the work that we did as electrical engineers is like what real electrical engineers do. So thank you for all of the work and thinking you did today. And if you think that that was exciting and want to think more about being an engineer, I did want to let you know that there are some other engineering activities that you can do. So if you go to the Science in the Summer website, you can see it up there. We have actually 4 different kinds of engineering activities. So the electrical engineer activity was just one. Some of you may have already done some of these already, or maybe you're going to do some of them. But if you haven't, feel free to check out the website and try out one of these other kinds of engineers. And if there's something you're interested in engineering that's not here, remember that there are engineers that solve all different kinds of problems. So if you're interested in a different kind of engineering, you could probably do a little bit of research and find out what kinds of problems they solve related to things that you're interested in. So thank you all for your work today. I also want to say thank you to GSK for making this program possible for us all to do. And I have just a few minutes left, so we'll just see if you have any questions or other things you want to share. Feel free to go ahead and put those in the chat. Right, Joseph says their favorite part was thinking of the stuff to make the circuit work. Yeah, those interesting problems to solve.